Hello, everyone. My name is Mr. Adebayo Abdullahi, your favorite IGCSE and GCSE curriculum biology and chemistry tutor. So today we're going to be looking at IGCSE chemistry, one of the most important topic, which when you understand it, 50% of your problem in chemistry is solved. So today we're going to be dealing with the periodic table. Now, we know that the periodic table is a table which shows the arrangement of elements in order of their atomic number. Now, the periodic table, the modern periodic table was compiled by a Russian scientist called Dmitry Mendeleev. Hence, the modern periodic table can be called Mendeleev's periodic table. There are over 100 chemical elements which have been isolated and identified. In the modern periodic table, you see 118 elements, including the lanthanide and the actinide. Originally, there were 103 elements, excluding the lanthanide and actinide. Now, in the periodic table, elements are arranged in order of their increasing atomic number. Like I said earlier, the periodic table is a table which shows the arrangement of elements in order of their atomic number. Now, each element has one proton more than the element preceding it. So this is done, the arrangement is done so that the elements end up in columns with other elements which have similar properties as it. Now, the periodic table, just like we said, a table is drawn in rows and columns, vertical columns. Now, I myself used to misinterpret or confuse columns and rows. We should understand that vertically, we have columns, and horizontally, we have rows. Now, in the periodic table, the vertical columns are called the groups, while the horizontal rows are called the periods. So generally speaking, the vertical columns called groups, in the periodic table, there are 8 groups, being group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 0, otherwise known as group 8. Now, in the periodic table, these number of groups are written in Roman numerals. So we have group I, II, until we get to group VII for 7 and group VIII for 8. Now, we should understand that periods are the horizontal rows. They show the number of shells of electrons an atom has. And there are 7 periods in the periodic table. So in the periodic table, we have period 1, 2, 3, and so on until 7. Now, groups, like I said earlier, are the vertical columns. They show how many outer electron and elements are. As we proceed further in this class, we're going to have diagrammatic explanation on how you can deduce the group and the period of an element in the periodic table. Now, the most important aspect of periodic table is what we call the electronic configuration. Now, the electronic configuration simply talks about the representation of the electronic structure of the atoms using electron shell diagrams. We represent the electronic structure of atoms using electron shell diagrams. Now, we should understand that an atom is made up of a center positively charged nucleus, a center positively charged nucleus, and the nucleus consists of the proton and the neutron. And around the nucleus of a cell or of an atom, we have shells, otherwise known as orbitals. In these shells, electrons revolve around the nucleus, and electron being negatively charged. So the force of attraction between the positively charged nucleus and the negatively charged electron is what brings about stability in the structure of the atom. Now, like I said, we can represent the electronic structure of an atom using electron shell diagram. And what diagram are we talking about? The diagram of an atom. The electron, as you can see, orbit the nucleus in shell. Now, each shell has a different amount of energy. What do I mean by each shell? So, an atom of an element can have multiple types of shell. For example, we have our center nucleus. We have the first shell, which is the K shell. We have the second shell, which is the L shell. We have the third shell, which is the M shell. We have the fourth shell, which is the N shell. Now, each of these shell or orbitals have limitation. They have limits to the number of electrons that they can hold. When drawing the electronic configuration or the atomic structure of an atom, it is important to understand that the K shell can take a maximum of 2 electrons, the L shell can take a maximum of 8, the M shell can take a maximum of 18. However, it cannot go beyond 8 electrons. Each shell cannot take more than 8 electrons. That is because of the electron must be evenly spaced. And because of stability in the electronic structure, each shell must not take more than 8. Now, K, L, M, N. So the first shell, second shell, third shell, fourth shell. Now, we should understand that each of these shells has different amount of energy. They have different amount of energy associated with them. Now, how does this come to be? The further away from the nucleus, the more energy a shell has. Definitely, out of the shell K, L, M, N, the one with the highest energy level is the shell N, being the furthest from the nucleus. Now, electrons occupy the shell that is closest to the nucleus. And like we said, that's the K shell, and it can hold a maximum of 2. Now, how do you feel electrons on this atomic structure, shell? When a shell becomes full of electrons, the additional electron must be added to the next shell until when the next shell gets to its maximum, then we can fill it onto another shell. Now, we should understand that in most atoms, the outermost shell is not full, and therefore these atoms react with other atoms in order to achieve a full outer shell of electrons. And all this is to attain stability. Now, in some cases, we should understand that atom loses electron to entirely empty the outermost shell. For example, if sodium is to react with chlorine, for example, sodium has a symbol of Na, and chlorine has a symbol of Cl. Sodium, being an electropositive element, has an outermost electron of 1. We have the first shell around its nucleus to be 2. We have its L shell to be 8 electron. It has an atomic number of 11, hence we have an extra one, which is 1. Now, sodium has it is an electropositive element, hence this outermost electron it has, it can donate it. In the case of chlorine, we have it as an electronegative element, which has an atomic number of 17. So we have around its nucleus 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And lastly, we have 1, 2, 3, 4, 5, 6, 7. This we have 2, 8, 1. This we have 2, 8, 7. In order to achieve stability, the electron of the sodium right here will be donated, sodium being an electropositive element, will be donated to complete that of the chlorine as an electronegative which accepts electron. Hence, both of these elements will form a compound known as sodium chloride, which is a stable compound. And why is that? Outermost electron down to deduce the electronic configuration of the first 20 elements. So we're going to have a table of elements. The atomic number. So our first element will be hydrogen. To move helium, helium has an atomic number of 2, just like we have lithium, 3, beryllium, being 4, boron being 5, carbon being 6, nitrogen being 7, oxygen being 8. Now, the K-share of helium can still take another element, another electron. So we have 2. Lithium, the K-share can only take a maximum of 2. Hence, the third electron will be on the L shell. Hence, we have 2, 1. Beryllium, 2, 2. Boron, 2, 3. Carbon, 2, 4. Nitrogen, 2, 5. Oxygen, 2, 6. Now, let's move forward. We have the next one, we have fluorine. Which is 9. We have neon, which is 10. Fluorine, we have 2, 7. Neon, we have 2, 8. Now we have sodium, which is 11. And from what we had earlier here, we know that the L shell can take a maximum of 8, hence the extra electron will transfer to the next shell. And sodium is 2, 8, 1. We have magnesium, which is 12, to be 2, 8, 2. We have aluminium, 13, 2, 8, 3. We have silicon, 14, to be 2, 8, 4. We have phosphorus, 15, to be 285. We have sulfur 16 to be 286.